Basic chemistry, matter. What's matter? Standard textbook definition. Yeah, anything that occupies space and has mass, that's matter. Anything that occupies space and has mass. I don't think I need to expand on that any further. States of matter. What are the states of matter?
Solid, liquid, gas.
Solid, liquid, gas. There's a fourth one, plasma. But we're not really going to deal with plasma because plasma is like the sun. And if we touch plasma, we will not do well. So, plasma, go again. You guys ever see a plasma torch? Burn through stuff, pretty amazing. Composition of matter. Matter is made of elements. An element is a substance that can't be broken down into a simpler substance. An element is something that can't be broken down into a simpler substance. How many guys have heard that the four elements are air, water, wind, and earth? Not true. Unless you watch The Fifth Element. Some of you guys have seen that movie. It's an awesome movie. You should watch it. Yeah. You know Dallas movie. Yes. Where can I find a handy list of elements? This right here. Table of the elements. That'll be here on the wall. I'm not going to ask you what's an element and what's not, but anytime you're in a science room or a teaching room, there'll be one of these on the wall. That's a list of elements. Is wood an element? It's probably plywood or particle board, but no, it's not an element. There's more than one element in there. What do I call something that has two or more elements? A compound. Those are two words you should know, element and compound. An element is on the list. A compound is two or more elements joined together. A compound is two or more elements joined together. So we got element, we got compound. There's two more words we need. Atoms and molecules. Atoms and molecules. An atom is one particle. One particle of hydrogen, one particle of oxygen, that's an atom. One particle of gold, one particle of mercury, that's an atom. A molecule is two or more particles together. Molecule is two or more particles together. Most of what we're going to be dealing with are molecules. Are molecules always compounds? No. You're breathing one right now. What am I talking about? O2. O2. And you're even breathing more. What? You're breathing in air. Some oxygen in it. What's there more of in it? Nitrogen. And see, that kind of is about to see the end of its life. O2 and N2, these are elements, but they're molecules because there's two of them. Does that make sense to you guys? Is everybody kind of okay? All right. Now, atoms and atomic structure. Take a look in your book, page 25. Those are models of the structure of atoms. There's two of them, the orbital model and the planetary model. The planetary model is overly simplified, is not true, but it's easier to imagine. That's what we're going to use. The orbital model, never mind. The orbital model is more realistic, but it's starting to get a little fuzzy. So if you want to think about it that way, you can. If you'd rather think about it in a planetary model, that's fine. Now you look, you'll see there's red balls, yellow balls, and black balls. A red ball on that drawing is a proton. Protons are positively charged particles. Protons are positively charged particles. They're found at the center or the nucleus of the atom. They're found at the center or nucleus of the atom. Neutrons don't have a charge, they're neutral. Protons are positively charged. Neutrons don't have a charge, they're neutral. They're also found at the center or in the nucleus of an atom. And then buzzing around on the outside, kind of like little planets going around the sun, you find electrons. Electrons are negatively charged particles. Electrons are negatively charged particles. They're buzzing around really, really fast. And you never know exactly where they are. You can't measure where they are. Which is why there's the orbital model with that cloudy, fuzzy stuff around it. We know they're around there somewhere, but we don't know exactly where they are. Those three things make up an atom. Those three things make up an atom. And while we're waiting for this to warm up, we'll just watch the little dog chemistry. The chemistry isn't hard, dogs can do it.
Welcome to Dogs Teaching Chemistry. Our second lesson is on the atom. All substances are made up of matter, and the fundamental unit of matter is the atom. Atoms are made of three smaller things: protons, neutrons, and electrons. Paige and Dexter are going to help build an atom. Protons are positively charged particles. Neutrons have no charge and are neutral. Protons and neutrons are located in the center or nucleus of the atom. Electrons move around the outside of the nucleus and are negatively charged. Electrons move about so fast that they form clouds that surround the nucleus of the atom.
You guys okay with that?
Yeah.
Now, let's chemistry people who've had chemistry before. What element is that? Helium. All right. How did he know that? Is he a wizard? You're close, but there's even simpler ones. No? Yeah, there's two protons. Two positively charged particles. Protons are the key to everything when we're talking about elements. If you look up here, see there's an HE up in the corner. HE stands for helium. That 2 means there's 2 protons. The number of protons defines what element it is. The number of protons defines what element it is. Now you can change the number of neutrons. I can add a neutron to helium, and it'll still be helium. But if I add a proton to helium, it becomes lithium over there on the other side. So the number of protons defined, this is that particular atom. By the way, that's called the atomic number. Atomic number is how many protons an atom has. Down here is the atomic mass, atomic weight is 1. This guy has 10 protons. Anybody know what element that is? That's neon. It has 10 protons and it has atomic weight of 20.1797. How many neutrons do you think that has? 10. 10 and 10 is 20. This 0.1797 comes from radioisotopes. It means there are a couple of neons that have an extra neutron, but it's still neon. Don't worry so much about that. You guys may have come across, you've heard of radioisotopes before. How many guys have heard of carbon-14 dating? Carbon-14 dating measures how much carbon-14 is something. Carbon is normally 12, 6 protons, 6 neutrons. Some carbons have 2 extra neutrons, they call it carbon-14. And when a living thing takes that in and uses that carbon, that decays over time, you can date something with carbon back to about 50,000 years after that. It doesn't work anymore because all the extra neutrons are gone. Atomic number, atomic weight. You guys okay? And here, protons and neutrons in the nucleus, electrons spinning around. How we doing, everybody okay? Let's see what else the dog shows us.
Let's try to figure out what element Paige and Dexter have made. Dexter is counting how many protons we have. That'll give us our atomic number. Looking at the periodic table, you can find the atomic number, which is usually located in the upper left corner of an element square. The atomic weight is the number located on the bottom, which is the number of protons and neutrons in an atom. Great job, guys! The element is helium.
Pretty straightforward, right? Is everybody okay? Anybody have questions about any of that? It's going to get worse. You need to know this first. We're good? Okay. Now those electrons racing around the outside follow some rules. The one we need to know is the rule of Octet. O-C-T-E-T-S, write it down. Rule of Octet, you'll see this. What does that mean? You'll see this. What does that mean? Y'all hear me? Mm-hmm. So let's take sodium. We're going to do a sodium here. So we have a nucleus. That's sodium. Look up on the periodic table of the elements and tell me how many protons sodium is going to have. 11. It's got 11 plus charges, 11 protons. Remember, protons are positively charged. So we'll do this. It's 11 protons, so it's got 11 positive charges. Now, in order for this to be a neutral or uncharged atom, how many electrons am I going to need to balance out the 11 pluses? 11 minuses. So I need 11 electrons, negative charges, to balance out the 11 protons that are in the nucleus. Does that make sense to everybody? 11 pluses, 11 minuses. Those electrons are buzzing around here really fast in the cloud. But they kind of have to follow rules. Rule of octets. they populate shells. The innermost shell or a racetrack around a nucleus will hold 2 electrons. Then it's full. It's a little tiny racetrack. It'll hold 2 electrons and it won't hold any more. What do you guys know about similar charges? These guys want to be close to each other or far away from each other? Far away from each other. Remember, opposites attract. Okay? Like things repel each other. So these electrons want to be far apart and they're flying around like this, going crazy. This is kind of small, so it only fits 2. So I've got 2 electrons, now I've got 2 negative charges, I need 9 more, right? The next shell, you might hear this called valence shell, orbital, something like that. The next shell is bigger. Now I draw it like this, but it really looks kind of like this in 3 dimensions. I don't have the art skills to make it look fancy. So we're going to forget about 3 dimensions and just do 2. So I can fit 8 electrons in the next orbital. Because it's bigger, it's a bigger racetrack. I can fit 8 electrons in there. So I'm up to 10 electrons now, right? I'm almost balanced, but I need 1 more electron. There's another orbital out here that's even bigger. There's another orbital. Put my last electron. That's what sodium looks like when it doesn't have a charge. It's got 11 protons in the middle, it's got 11 electrons flying around on the outside. Everybody okay? Yes?
So is the rule about X that the electrons have equal to protons, or is it about the?
We're getting there. That's a great question. We're not quite there yet. Everybody's okay with that? The rule of octets describes how many electrons can fit in each shell. The rule of octets describes how many electrons fit in each shell. And if you look over here, along this side of the periodic table, kind of small, so when you're taking your test, if you sit on this side of the room, it might help. You'll see that there's a 2, 2, 8, 2, 8, 8. It goes 2, 8, 18, 8, 2, 8, 18, 18, 8, 2, 8, 18, 32, 18, 8. The shells get bigger and bigger and bigger as you go out. The cool part about this class is you only need to remember 2, 8, 8. You only need to remember 2, 8, 8. Because we don't go much bigger than this in organic chem. Lesson. 2, 8, 8, rule of octets. The innermost shell has 2 electrons, and then it's full. The next shell has 8 electrons, and then it's full. And the next shell has 8 electrons, and then it's full. For this class, you don't need to go any further. How do you feel about that? Okay, question?
When the outermost shell has 8, is that what creates valency, or is that something different?
Let's leave that alone for now. Let's just say it's full and it's happy.
Okay.
That'll be better.
Why is it just one row 2, 8, 8, but the rest are 2, 8, 8?
Because when you get to here, first shell's always 2, can only ever hold 2. Second shell's always 8, can only ever hold 8. Third shell, it likes to be full at 8, but if you slam a whole bunch in there, you can get it up to 18 and it rolls out there. It's just, it's has to do with bonding, and we're gonna talk about them being satisfied. This second 8 is still pretty close. The further you go, the further they are away and the easier they are to strip off. So these guys you can strip down pretty quickly. By the time you get here, you got a whole bunch more electrons on. They're easy to strip off. And it settles down at this, it becomes non-reactive. These guys in this column are called noble gases because they don't react with anything else. They're just cool by themselves because their shells are full. This guy here has 1 less. This guy here has 2 less as you go down. Does that kind of help at all?
Yeah.
Okay, go ahead.
So, where it says 18, so that shell is actually further out and bigger.
Further out and it's bigger, it goes out here, it goes out here, it goes out here,
So you
yeah.
can hold more without them being too quick.
Right, right. It's like 8th graders.
Yeah.
You can have a couple in a room, but if you have too many room, it breaks down, so you separate.
That's why sodium is so reactive.
Yeah, that's why sodium is so reactive. We're gonna talk about that in just a minute. Everybody okay with rule of octets? This has major implications for forming bonds. I form a bond when I react to atoms or molecules together. And it changes them chemically and they stick together permanently. That's something else I should talk about. We talked about compounds, right? Compound is 2 or more atoms together. I mean, two or more elements together. But that's if they chemically react together. I can have a mixture. There's 2 things mixed together, but they're not chemically bound to each other. If I take salt, a cup of salt and a cup of sugar and pour them together and mix them up, it's still just salt and sugar. And if I had a lot of time, I could probably sit there with a microscope and pull the crystals apart again without doing anything chemically. That's a mixture. A compound is if they're joined together. If I take sugar and saltpeter and light it on fire, it makes lots of black smoke, it makes snakes. Do you guys know what a snake is? The little pellets that you light, puts the ash out, that's old school fireworks. It's just this little puck that you lit, and some ash came out and made things look like a snake. Yeah, I'm old, they don't do that anymore, I guess. But, that's a chemical reaction and you get a compound. A mixture is when you just mix stuff together. Alright, don't worry about that, you probably know it already. So, electrons and energy levels. Rule of octets. Everybody happy? Now, chemical bonds. The chemical bonds part is pretty important. This is how we put molecules together. The chemical bonds part is pretty important. This is how we put molecules together. There's different categories of bonds. If you look in your notes, ionic bonds are one category. Covalent bonds are another category. And there's 2 different kinds of covalent bonds. There's 2 different kinds of covalent bonds. Non-polar and polar. So that's 3 bonds. The 4th bond is hydrogen bonds. 4th bond is hydrogen bonds. We're going to look at each one. But I want you to know there's 4 different major kinds of bonds. Ionic, non-polar covalent, polar covalent, and hydrogen. Everybody all right? In general, ionic bonds happen when one atom takes electrons from another atom. Ionic bonds happen when one atom takes electrons from another atom. That's
Welcome to Dom's Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell.
How many valence electrons does sodium have? 1. It's got 1 in the outer shell. Here's another reason why the rules of octets are important. This is stable. There's 8 electrons in there. That's not going to leave. These atoms really want to have 2 or 8 or 8 electrons in the outer shell. When it has 2, 8, or 8, 8, its valence is not going to react. The noble gases over there, they're not going to react with anything. If there's a different number here, in this case, we're looking at 2, 8, 1. That's what sodium looks like. It really wants to have either 8 here or 8 here. Is it going to be easier to lose 1 or gain 7? Easier to lose 1. Right? Sodium's going to be really happy to get rid of that extra electron, which will make it have 8 on the outside shell, and it's going to be happy. Let's watch some more dogs.
Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion.
Alright, important stuff just happened. There's our sodium. It's got 1 electron out there that it really wants to get rid of. Sodium is really, really reactive. If you have sodium metal, just sodium in a chunk, you have to keep it in kerosene or something like that because it will react with the water in the air. There's an urban legend among chemistry teachers. Little Johnny was in 9th or 10th grade and the chemistry teacher did a demonstration. He plopped a little piece of sodium into water and it actually catches on fire. It'll float, spit around on top of the water. It actually catches on fire. The reaction is so strong. Well, little Johnny wanted to do this at home, so he took the entire chunk of sodium from the chemistry supply room, put it in his pocket, and was on his way walking home. Well, the kerosene that was on the outside rubbed off, and his pants caught on fire. And he burned himself badly because he didn't know about chemistry. Urban legend, but it could happen. Sodium really reacts. If you Google or go to YouTube and look for sodium water reactions, they'll have them. If you want to get really crazy, potassium, rubidium, cesium, big explosions. You guys used to watch Top Gear with Richard Hammond, what I'm talking about? He actually has some science videos as well. If he does that, he throws chunks of metals into a pond and it makes big explosions. Sodium really wants to get rid of that electron. Well, there's an easy way to do it. We're going to make another atom here. Chlorine. Look up there and tell me how many protons chlorine has. 17. So there's 17 pluses. There's 17 pluses, 17 protons. How many electrons are in the first shell? 2. Always 2. How many in the next shell? 8. So it's full. And we got our next shell too. How many are in this next shell? 7. There's 7 in the outer shell. What does it want to have? 8. Rule of octets. It wants to have 8. is it gonna be easier to ditch 7 or grab 1? It's gonna be totally easier to grab 1. Where could we grab 1 from? Sodium really wants to get rid of its 1. Chlorine really wants to have 1. So, chlorine takes sodium's electron. Chlorine takes sodium's electron. What do you guys know about elemental chlorine? The chlorine gas. Very poisonous. Really poisonous, toxic. They used it to kill each other in World War I. In the trenches, they'd have chlorine gas attacks. And the chlorine gas would be yellow-green and roll across the hills and sink down into the trenches. And if you breathed it in, it would make your lungs swell and fill with fluid and you would die. Chlorine is tough stuff. If you want to try that at home, just mix bleach and ammonia. You know not to do that, right? If you mix bleach and ammonia together, you generate chlorine gas and you can die. Somebody died not too long ago in Indian Rock Beach. They were cleaning their bathroom. Oh, ammonia is a good cleaning product. Look, bleach is good too. Let's mix them together. They mixed it up in their bathroom and they died. Chlorine is pretty bad stuff. Now we've made some changes here. We have 11 protons, but we only have 10 electrons. I got 11 pluses and 11 pluses, 10 minuses. So now I have a charge. What charge is this going to be with 10 pluses and 11 minuses? 11 pluses and 10 minuses. It's going to be a positive charge, right? I got 1 extra plus, right? Y'all with me? 10 minuses, 11 pluses. So this has a big old positive charge. Chlorine here has 17 pluses and now it has 18 minuses. So what charge is this? Negative charge. Chlorine has a negative charge. So these two guys stick together because opposites attract, right? Yeah. You didn't know that, write it down. Opposites attract. Just like life. Pluses and minuses. She's so nice. What she do with him? Yeah. Opposites attract. Plus and minus stick together. That is an ionic bond. Those two chemicals stick together. Now if I take sodium, which sets your pants on fire, and chlorine, which kills you with bad gas, and react them together and eat it, what happens to me? But yeah, I just made salt. Nothing happens to me except my blood pressure goes up a little bit. And I just made salt. From metal that catches your pants on fire and gas that kills you when you breathe it in. The chemistry is kind of cool. We just went, whoa. Nobody? Oh, well. Okay. That helps me go well anyway. Alright, that's an ionic bond. They're attracted to each other because they have different charges. Now look at our dogs up here. Anything that has a positive charge on it, any ion. By the way, ion means charged particle. Write that down. An ion is a charged particle. Cations are positively charged particles, and anions are negatively charged particles. Cations are positively charged particles. Anions are negatively charged particles. Because opposites attract, they stick together. Because opposites attract, they stick together. You can remember cation is positive because you just picture a little kitty there. Oh, isn't that cute? Little kitty cation, that's a positive thing. For anion, taking a bite of an onion, big old onion. Yeah, negative. Cations are positive. Everybody okay? Ionic bonds occur when one atom takes another atom's electron. Those guys break down in water. You put something that's held together with ionic bonds, it breaks apart in the water. We're gonna talk more about that when we do solubility. But for right now, the ionic bonds break down in water. Ionic substances dissolve in water. Substances with ionic bonds dissolve in water. Those are ionic bonds. Covalent bonds occur when two atoms share electrons. Covalent bonds occur when two atoms share electrons. The degree of sharing determines whether it's polar or nonpolar. The degree of sharing determines whether it's polar or nonpolar. Nonpolar covalent bonds share electrons equally. Nonpolar covalent bonds share electrons equally. Polar covalent bonds occur when atoms share unequally. Polar covalent bonds occur when they share unequally. This is an atom. We're going to make a bond. We're sharing equally, right? This would be nonpolar. This would be polar. Unequal sharing. Does that make sense? Everybody's okay? Alright. Sorry for both of you for the attention.
Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by two atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
Alright, you want me to do a drawing of some of this stuff? Covalent bonds share electrons. Polar covalent is unequal sharing. Non-polar covalent is equal sharing. I was all proud. I got these fancy new pens. They're even refillable. I'm trying to save money. These don't work as well as the other pens. They're not very bright up there, are they? Did you guys see in like the back corner? Are you guys okay seeing the stuff up here? Okay. That makes me feel a little better. I'm not real impressed with the green and the blue. We'll try the red and the orange. I know black works. All right. Carbon. How many protons does carbon have? 6. How many electrons in the first shell? 2. How many electrons in the second shell? 4. Now, just because it is, carbon wants to pick up 4 electrons. Because it does. No reason why, it just does. We can talk, we don't want to talk about why. It just does. One way carbon can do that is to pick up some hydrogen. How many protons does hydrogen have? 1. So how many electrons does it have? 1. So I can add a hydrogen here. That's correct. There we go. If I add a hydrogen there, hydrogen brings 1 electron to the party. It's going to play with 1 of carbon's electrons. Hydrogen's happy because it has 2 now. Carbon is happier because it has 5 instead of 4. Does that make sense to you guys? Carbon's a little happier, hydrogen is happier. So I'm going to add 3 more hydrogens. Another one up here. Another one here. Another one down here. So now I've got, each hydrogen has 2 because it's sharing equally. The carbon has 8 because it's sharing equally. They want to stick together, hang out because everybody's happy now. Everybody has a full outer shell. Does that make sense to you guys? It's equal sharing, so this is non-polar. Oxygen. How many protons does oxygen have? 8. How many in the first shell? 2. How many in the next shell? 6. Does oxygen want to pick up 2 or lose 6? Let's pick up 2. Guess what? We can do hydrogens again. Now, each hydrogen is happy because it's got 2. Oxygen is happy because it's got 8. Right? Everybody's happy. Except, oxygen's a bully. Because of reasons, oxygen monopolizes the electron. This isn't how it really works, but let's pretend. This hydrogen electron is going to spend a whole lot of time going around the oxygen, and not much time going around the hydrogen. Same thing here. That's unequal sharing. If you got a younger brother or younger sister, or an older brother or an older sister, you know what unequal sharing means. When mom and dad brought home a new toy, the older one got to play with it, right? More, unless mom and dad yelled. Unequal sharing. Because of this, charges occur on that molecule. This end of the molecule is going to be negatively charged. This end of the molecule, these ends, are going to be positively charged. Because the electron is spending most of its time hanging around with oxygen, not hanging around hydrogen. So we got a negative end, we got a positive end. 2 positive places. This is polar covalent bonding. That is polar covalent covalent bonding. Does that make sense to you guys? Everybody's all right? Just on general principles, covalent bonds are probably the strongest bonds we're going to talk about. They're really tough. Ionic bonds will break apart in water, so they're not quite as tough. Covalent bonds are really strong. Now let's talk about what dissolves in water a little bit more. We know ionic substances dissolve in water, right? Sugar dissolves in water. Polar covalent molecules dissolve in water also. That is water, H2O. You guys notice that, right? Two hydrogens, one oxygen in water. What's the other one? CH4, what is that? CH4? CH4? Ring any bells? Come on, chemistry college people. What's CH4? Methane! Oh yeah, we just said oh yeah. Methane, or if you're English, methane. They call it methane. I don't know why it's methane. English are weird. You guys know where methane comes from? Yes. If you're walking through the swamp and the bubble's coming up, it smells like sulfur. It's methane gas. It's sulfur production from bacteria, but it's methane gas. It also comes from your farts. How many guys have seen a video where somebody lit their fart? Most of you have looked that up. How many of you have actually done it? Nobody wants to admit it? I guarantee you somebody in here did.
I'm a brother.
Alright, yes. Yeah, brothers are weird. That's non-polar covalent methane. Polar covalent water. Polar covalent things dissolve in water. Non-polar things don't. Non-polar things don't dissolve in water. We're going to talk more about dissolving in probably next class. All right? Hydrogen bonds. Hydrogen bonds are different than these guys. The big differentiating factor is hydrogen bonds occur between molecules, not atoms. Write that down. Hydrogen bonds usually occur between molecules, not atoms. I don't want to see that. I apologize. That was like once. Okay. You all survived. Did you know what I see what I typed in here? Hydrogen bonds easy. How many guys are already using the internet as a tool for helping you study stuff? If you're not, you should be. Right now, there are thousands and thousands and thousands of students taking AP1 like the same week you guys are in. Probably hundreds of thousands across the US and other places. Use this, there's tons of stuff on here. Now, if you don't put in easy, you get huge intermolecular forces, blah, blah, you get all kinds of stuff. How many guys know about Crash Course? Crash Course is freaking awesome. It's a great tool. It's 10 minutes, so I'm not going to use it here. But I will remind me, I'll show you guys a Crash Course video.
What are hydrogen bonds? An attractive force called a hydrogen bond can exist between certain molecules. These bonds are weaker than ionic or covalent bonds because it takes less energy to break these types of bonds. However, a large number of these bonds going on can exert a strong force. Hydrogen bonds are the result of an unequal charge distribution on a molecule.
Look, there's water. Slightly positive, slightly negative. Hydrogen bonds give water a lot of its special properties we're going to talk about next class.
Molecules are said to be polar. If we look at a water molecule, we can see the oxygen atom shares electrons with two different hydrogen atoms. So, in total, this molecule has 10 protons, 8 from oxygen and 1 each from the hydrogen atoms, and a total of 10 electrons, 2 shared between the oxygen atom and hydrogen atom number 1, and 2 shared between the oxygen atom and hydrogen atom number 2, and the other 6 non-shared electrons from the oxygen atom. So this water molecule is electrically neutral, but it has a partial positive side, the hydrogen side, and a partial negative side, the oxygen side of the molecule. The electrons are not shared equally within the molecule, as they have a higher probability of being found closer to the nucleus of the oxygen atom, giving that end a slightly negative charge. So the hydrogen atom's end of the molecule will have a slightly positive charge. These charge ends weakly attach the positive end of one water molecule to the negative end of an adjacent water molecule. When water is in liquid form, there are a few hydrogen bonds. Solid form, many hydrogen bonds, and when water is steam or gas, there are no bonds because the molecules are too far apart to form any bonds. Hydrogen bonds only form between hydrogen atoms that are covalently bonded to an oxygen, nitrogen, or fluorine atom. Hydrogen bonds are also important in the structure of proteins and nucleic acids, which we will cover in later videos. So now,
Okay, that's really important. I want you guys to recognize this. Hydrogen bonds help form things like DNA. Hydrogen bonds help form things like DNA. How many of you guys have seen the double helix of DNA? Seen a picture drawing, something like that, of the double helix of DNA? Pretty much everybody, right? So if I take that double helix, kind of like a spiral staircase. If I take that double helix and stretch it out, kind of looks like a ladder, right? Y'all with me? This is actually two strings joined together. And in here, these spaces between the rungs of the ladder, those are held together by hydrogen bonds. Hydrogen bonds are nice biologically because I can unzip that. I can pull them apart, not change the chemistry at all. I'm not busting any chemical bonds. And I can read the DNA, then I can put it back together unchanged. That happens in every cell of your body every day. Your DNA gets unzipped, read, and zipped back up again because it has hydrogen bonds holding it together. So hydrogen bonds help give shape to a lot of molecules. Does that make sense? Guys okay? Are you okay with hydrogen bonds? Hydrogen bonds are kind of the weakest bonds. They occur in water, other places too, between certain molecules. Everybody all right? Okay. Time to go. We got some time for some definitions. Chemical reactions definitions. A chemical equation is a sentence that describes what happens in a chemical reaction. Chemical equation is a sentence that describes what happens in a chemical reaction. Let's take a look through your book. If you look at page 27, there's some more atomic structure. And then let's go to page 32 and 33. There are some ionic and covalent bond examples. Page 35. There are some hydrogen bond examples. How many of you guys have seen water skiers before on the pond? See a picture of them there? You know, if you take dish soap and go around it, they sink. Don't ask me how I know that. I was an evil little fifth grader. You break the surface tension of the water. And then, let's take a look at page 36. In the text, not in the pictures, in the text, you'll see some representative chemical equations. That describes what's happening. Reactants are what you mix together. Products are what you get with a chemical reaction. Reactants are what you mix together. Products are what you get from a chemical reaction. You start with the reactants, mix them up, burn them, do whatever to them. They react, you get products. Everybody comfortable with those terms? Actives and products? I think I already told you this. Give me a definition for metabolism.
All the chemicals react with the one body.
Nice. The sum total of all of the chemical reactions in your body. The sum total. All of the chemical reactions in your body. Now, more words. Synthesis reactions take smaller molecules and make a larger molecule. Synthesis reactions take smaller molecules and make a larger molecule. Decomposition reactions take a large molecule and break it into smaller pieces. Decomposition reactions take a large molecule, break it into smaller pieces. Exchange reactions do both. You're breaking one apart and building up another one. Exchange reactions break one molecule down and build up another one. Most reactions in your body are exchange reactions. Now there are some fancy words there you need to know. You see anabolic and catabolic? Anabolic means build up. Catabolic means break down. Know those words. Anabolic means build up. Catabolic means break down. You can remember that because what happens when you take anabolic steroids? You get all muscly, right? Bad things happen when you take anabolic steroids, right? You guys know not to do that? You know why? When you take anabolic steroids, you build muscle, but it also messes with your body chemistry. You get a lot of acne. You guys hear roid rage before? You get mad all the time. You got lots of zits. You got big muscles. It also makes your testes shrink. Because you're putting that in your body and you don't need your testes anymore. So if you're trying to be all buff, whether it's for females or males, same result. You're all buff. You want to go out and get some action, but you got zits all over your face, you got a bad attitude, and your junk doesn't work because your testes are the size of raisins. Don't do steroids. Steroids are bad. Any questions? What did we learn today? Don't do steroids, right? Questions, comments, concerns? Fly be free.